Hi, year 11s, this is Mr. Lim here, and this is our final video on energy changes about how to do them calculations. Alright, so we're going to learn how to do some chemical calculations again, but this time adding the energy numbers in there. Alright, so thermochemical calculations, so the delta H value in the thermochemical equation represents the energy gained or lost by the system. When the coefficient number of moles are used in the reaction, we knew that already. That means you can calculate the energy change during a chemical reaction, just like the mass or moles of a reactant or product. Okay, the equation is this here: the energy change is equal to the number of moles of a substance divided by the coefficient of the substance times the delta H of the reaction. Okay, so this is effectively how much energy is gained or lost when a certain mass or moles of a reactant or product is in a reaction. Okay, you rearrange these equations, so you have to work out the number of moles, or you can work out the delta H from these things here. Okay, so let's go through a couple of examples. Right, so ethanol is burnt in excess oxygen to form carbon dioxide and water. Change in enthalpy for this reaction is 1360. Okay, balanced equation. So CH3CH2OH. Okay, plus O2 goes to CO2 plus H2O. All right, so 2 carbons here, 3 hydrogens here. Okay, how many oxygens I got? 7, so I need 3 here, and that's a balanced equation, and so I'm going to put in the extra energy. Okay, so delta H is equal to 1360 kilojoules, and it's an exothermic reaction. I only know that because you're burning something, and burning something effectively makes lots of heat to the surroundings, and so therefore it is a exothermic reaction, but I probably should have wrote that in the question. All right, so determine the amount of energy released if 40 grams of ethanol is burnt in excess oxygen. So first of all, we work out the number of moles of ethanol as 40 over the molar mass of ethanol, which happens to be 46.068. Okay, 40 divided by answer 0.868 moles. All right, then I can use the equation that we've got before, which was this one here, the red one. The energy change is equal to the number of moles of a substance divided by the coefficient of a substance times it by the delta H. All right, so energy change, so we would write, and we can just use E here, energy from the CH3CH2OH is equal to, I'm going to save that value as A, so A over the coefficient of A, which happens to be 1, times 1360, which equals to 1180.9 kilojoules released. Okay, nice and easy. Right, determine the amount of energy released if 38 grams of 40% pure ethanol. Okay, so then I have to work out the mass of it first, and this is the pure stuff that I want, which will be equal to 38 times 0.4. Okay, so 38 times 0.4, 15.2 grams. Then I can work out the number of moles of my ethanol as 15.2 over 46.068, which will be equal to some value. Point 3 mole, right? And then I'll save that as, well, I can save that as A, I guess. Saves A, right? Then I'll get the energy again. All right, so exactly the same way that I did before. There should be some value. 44 8.7 kilojoules released. Okay, let's move on. Determine the mass of ethanol consumed in a reaction if 4,600 kilojoules of energy is produced. Okay, so this is now using a different version of that equation. It's the blue version where you're working out the number of moles and thus the mass of something. Okay, so, we are going to be using number of moles of the CH3CH2OH is equal to energy change, energy change times coefficient over delta H, which will be equal to 4,600 times the coefficient, which happens to be 1, over 1360, which will be equal to 4600 divided by 1360, 3.38 mole. Okay, and then I can work out the mass of ethanol from that, which will be equal to that value times 46.068, right? 46.068, 155.82 grams. Okay, so that's that. And then determine the mass of air required to burn with 20 grams of 70% pure ethanol if 21% oxygen gas is used. Right. This is not even asking for a energy calculation. Why did I write this in here for? No, well, this is a good opportunity to do some stoichiometry, right? No, it's not. Let's just skip to the last question. You can do this on your own, right? Methanol is closely related to ethanol. Burns in oxygen produce the same products. If 20 grams of methanol is burnt in excess oxygen, produces 409.5 kilojoules of energy. Determine the enthalpy change of the reaction. So this is solving for delta H. So first of all, let's write out the equation. CH3OH plus O2 goes to CO2 plus H2O. Right, so this will take a bit of balancing. Put a 2 there, and then I have 4 oxygens on the right and 3 oxygens on the left, but I can't have that, so I'm going to put a 2 there, I'm going to put a 2 here, I'm going to put a 4 here. Okay, so now I have 8 oxygens on the right and 4 oxygens on the left, so I'll put a 3 there, and that's a balanced equation. Right, so if 20 grams of methanol is burnt in excess oxygen, it produces that many things. So I need to work out the number of moles of methanol. Okay, because that will be useful. So that'll be 20 grams over the methanol. So that is 12.01 plus 4 times 1.008 plus 16, which will be 32.042. 20 divided by that is equal to 0.624 moles, which will save as A. All right, so now I have the energy and the moles. So now I can work out the delta H. The delta H will be equal to the energy times the coefficient and divided by the number of moles of the substance. Okay, so that will be the energy 409.5 times the coefficient, which happens to be 2, over the number of moles, which happens to be A. Okay, so that'll be, that's A, yep, okay, still A. Yep, so therefore it's 409.5 times 2 divided by alpha A, which would be 1312.12 kilojoules. Okay, and so therefore I could write that out as delta H is equal to 1312.12, but then I got to read the read the question, and it says that it produces this much energy, which means that it's an exothermic reaction, which means it's going to be a negative value there. Okay, and that's how you do variations of the the thermochemical equation. All right, so have a go at those questions in the booklet, and then we'll see how we go. Adios.